Okay, good morning, guys. So, just a video support for physics, since I think we may run out of time because we don't have a class for 2 days. So, physics, topics, dynamics, problem 23. A 2 kilogram box is moving to the right with a speed of 9 meters per second on a horizontal, frictionless surface. At time is equal to 0, a horizontal force is applied to the box. So, we can envision it to be. Where's my pen? Oh my, where's my pen? Where is my pen? Okay, there's a pen. Maybe I can try to draw it. And of course, you have your box. Ooh, it's perfect. Then I will put some so that it would appear as maybe I could just place. So it's moving here with an initial velocity VO of 9 meters per second. And then at time is equal to 0, a force is applied, which is of course going to the left side. That's what the problem says. F. Okay? So that's how I envision the problem is. The next question, your force is actually a function of time. So what distance the box move from its position at t is equal to 0? So actually, since your force is not constant, basically your acceleration is not constant. So basically, you cannot use kinematics equation here because again, your kinematics law applies to kinematics law. Your four equations for kinematics only applies when your acceleration is constant. Again, but still, your second law of Newton's second law would still apply for this matter. What your second law states, that the summations of forces, here we will just restrict it on x, because that's where the acceleration is coming. So again, that acceleration will be contributed because of that summations of forces. So if the acceleration is only on the x, so you only need to use the x on the summations of forces. Okay? And also you can take note that you don't have a normal force for this because there's a normal force, but there's no connection between your normal force and the summations of x. Usually there is if there's a friction because you have an equation for your normal force with respect to frictional forces. Since there is no friction, the problem says, therefore your summations of forces on x will just be equal to your f, which is actually going to the left. So as you've read your book, your velocity is going to the right and your acceleration because of your f going to the left. So basically, this will stop because you have a deceleration and descents. The summations of force on x would still be equal to f, and that would still be equal to m and a. But this again, a is not constant, so therefore we cannot resort to kinematics. So meaning we will go to our equation for non-kinematics equation, meaning those which involves non-constant acceleration, which I think there were two. The first one is the Vx is equals to Vo plus your integral of your Ax dt from 0 to t. So that's your first equation. And then you have another equation, which as you can see, this is what the problem asks. The x, the distance. So you could just imagine if there's a initial velocity for this, and then a constant force is applied to this, there will come a time that that box would actually stop because there would be an acceleration which is negative. Okay, that negative acceleration is actually a deceleration, meaning that velocity will come to halt. Just like throwing your piece of stone going up, it will find its final destination. But here it will stop since it will stop, and maybe after time 0 it will now go back to the left because your only summations of forces here is going to the left, just like your free falling bodies when you throw it upside. So that distance is actually this one. This x here is actually the velocity x here, which is actually given in the problem before it stops. So at the moment it stops, actually, or Vx is equal to 0, you can already compute how far it have gone from this point in time. So that is actually the question, the x, which is xo plus your integral of bx dt. Okay, you have two equations for this. So, but you need this one if you started with origin, meaning at times equal to 0, you assume a 0 position, so this will be 0. You assume because there's no given distance, so you can assume a 0 point as an origin. Okay, so that is common. So you read your book, this is common. So meaning your x would just be an integral of dx dt. Now your vx is given as a function. Again, your VO is given 9 meters per second. So this would be 9. So maybe I could start my solution here. Your Vx actually is a function of time would be equal to 9. Let's just put the units a later time. Okay. So that we won't be hassle with it. And then you have your 0 to t, you have your a dt. And your a is actually given by your second law. Your a here is equal to f all over m. Okay, so we can 9 plus, we can substitute your acceleration here, 0 to t, you have your f all over m dt. And your f is given as a function of t, so which is 6t squared. So let's just put first the 6, but we know that we have a unit for that. Just let's put the units after. So you have 0 to t, you have your 6t squared all over m dt. Okay, that is your vx. So you don't have a time actually, but you can solve for that time because you have already your equation for vx. I mean, setting this vx to 0 before it stops. You can compute for that time. Before it stops, what is the time it take from this point before it stops? So that's what it says. So you can 9 plus, you can factor this out because that is a constant. 6 all over 2 kilo. So you know that that is 2 kilo. We'll just put the units there. And you have your 0 to t. Then you have t squared dt, which is equal to 0. Okay? And then actually you can already, I mean, let's expand further. T squared dt is equal to negative 9. Ooh, you have a 9. Is this a plus? Anyway, your acceleration there should be negative. But anyway, let's just proceed. That would be a negative 9 meters per second. And then you have your 6, what's the unit? Newton per second squared all over your 2 kilogram. I could put it here, meaning I have a integral of 0 to t. You have t squared dt, which is equal to 2 kilogram. And then I could put your 6 Newton into somewhat 6 kilogram meters per second squared. That is your 6 Newton. Of course, it will reverse here. Okay, ada boss. And then, may dapay per second squared. Per second squared. Okay? And then you have your um, multiplied by negative 9 meters per second. So you can cancel the kilogram. I could cancel the meter. And I could cancel what? 1 of the seconds. This actually is second to the fourth, actually, at this side. Seconds, both of this is actually per seconds square. That would be second to the fourth. But this one is meters per second. Actually, adi na tiya igbaw, second to the fourth. So you have one that will be Tanggala, if you have second cube at the top, okay? So it will look like this. 2 over 6, and then you have a negative 9. The unit now would be second cube, actually, because this 2 will go up. Okay? And then you have the integral of this, of course, cube. That is t cube all over 3. Oh, we would have a negative time. So that's the problem here. We shouldn't be getting a negative time for this. Where is our negative time? Why? Your f is going to the left. So this should be a negative. Negative f is ma. Your acceleration is, actually your acceleration is going to the left. It should give us a negative. But from the formula, it's actually right, because we haven't still solved it. So that would be a negative f. So I think that should be a negative f here. So if that is a negative f, that should be a negative here. This should be a negative here. And that would give us a positive 9. So this is already a positive 9. Okay, that's already a positive 9. Okay, so we have the t cube, which is equal to 2 times 9 times 3 all over 6. So we can cancel out the 3. So you have 9 second cube, t cube, and then you cube this one, 9 cube. So you have time, which is equal to 9 cube, the cube root of 9. So the cube root of 9 is 2.08. So time is 2.08 seconds, or the cube root of 9. Okay, so I've already have the time. So basically, I could already solve the x, um, substituting it here. Therefore, your x is equal to the integral of your vx, the integral of your vx, which is, of course, we have to substitute it back for your vx. Where is our vx here? I think our vx is this side. Yes, this is the vx. The vx is, we will just be having it as this guy over here. Okay, I mean dirita hiya solve na that may t, because still this is a function of t, meaning we have to substitute the vx. Substitute na lang. We have the 9, the integral of 9 plus the integral of 0 to t. Then you have your negative f, your 60 squared. 60 squared all over m dt. That's how it looks like. Okay, but this one still integral of 0 to time t. So x, that would be, of course, that's how it looks, 0 to t. Then we have 9 plus, we can extract again our, this will be negative, 6 all over m. Okay, the integral of 0 to t dt. Of course, this is still dt, vx dt. These are all still dt here. Okay, so double integral sum mod. So 6 dt, um, t squared, sorry. That would be t squared, and then this will be dt. Okay? And then another dt at the outer side. So you have 0 to t, 9 minus 6 all over 2. And then you have the integral of that would be a t cube. Actually, I've solved it already in that side. T cube. Okay, all over 3. Okay? But still, that is a function of dt. So you have um, 0 to t, and then you have 9 dt minus 0 to t. You have 6, you have t cube. T cube dt. Okay? So, finally, you have 9, 0 to t dt minus you have your 0 to t t cube dt. So, given that our units are right, so anyway, so pwede tayo diretso calculator. So, 9, the integral of dt, 1. So, from 0 to a time, um, square root of 9, I mean the cube root of 9. So, ibubutang ko lang cube root of 9 para kung then multiplied times 9. So, you have a 18.7. You have an 18.7 meters here minus. So, you have your t cube, your integral of alpha x cube dx from 0 to the cube root of 9. See? So I'll just input it in. So your calculator will give us the answer, of course. So this is not a integral subject. So bisan diri ka mo by calc na lang, okay lang ito. Waray problema. So you have a 4.68 meters. And finally, you have an 18.7 minus 4.68 meters. And you will have a 14.02 or 14 meters in in three significant or two significant figures. Depends on the problem, of course. You look back at the problem, usually tag 3. So usually your answer must be in three significant figures, and my answer here is 14.02. So that is 14.0. So in three significant figures, that is 14.0 meters, and that will give us our first letter A for the distance. Ha? Kita ni dynamics mo pala pag sinulbaron. Okay, let's continue with our problem. So letter B, if the force continues to be applied, what is the speed of the box at 3 seconds? So waray igundang an imo. Okay. If the force continues to be applied, what is the speed of the box at 3 seconds? Actually, we've already solved that at time 2 seconds, 2.08 seconds, the box will stop. Actually, if that's force still there, even up till time 0, because that's only time. So the force, if the force still continues, it will stop, and then it will go to the left already. So we can expect a negative velocity for this. Because again, our velocity to the right is assumed to be positive as given from the problem. So actually, you already have you should, if you're solving actually a problem, you should already have that sense of what your answers might get. Okay? So just like throwing a ball to top, you have a negative acceleration for that. That's why after it stops at the highest point, it will go back again. So anyway, actually you're just solving this guy over here. You have a VO, you have an acceleration which is a function of force, which is a function of time, and you have a dt, and then you're solving from 0 to a time 0. So actually that's a direct from bicalc using your um, this guy over here. So we'll just continue that one maybe. we can just says for letter B, actually, you just have to say that Vx, gumutin ako agi, pero ako dakuan ko. Sa Vx is equal to Vo. You have your 9 meters per second, and then plus, again, that is a negative acceleration, that is a negative F all over M dt. Substitute your F 0 to time. Your negative F is given from the problem. That is a function of time, 6t squared. So that is a 6 t squared all over 2 kilogram. Okay? dt. And then we put the units, 9 meters per second plus, you have your negative 6 Newton per second squared all over 2. So I'll just revert back to meters per second squared. So 2 kilograms. So that this kilogram would be cancelled. So the unit now is meters per second to the fourth, and then 0 to time. And then you have your t squared dt. So this is already, given that we have the right unit, so this should spit out a t cube. T cube. So second to the fourth, that you would have a, sorry. So this is already minus because of the negative for the 6. I'm really sorry, guys. So you would have already 9 meters per second minus 6 all over 2. Units for this is meters per to the second to fourth. And then you have an integral of 0 to t squared dt. And then you can have your calculator, 9 meters per second minus, that is 6 over 2, that is 3. Then multiplied by the integral of 3 multiplied by the integral of alpha x squared from 0 to 3 seconds. And that would give you 27. Ooh, 27 meters per second. So you have 9 minus 27. That should give you how much? 21? No. 9 minus 27. 18. So that is a negative 18 meters per second. So that would be the asked velocity. What is the speed? So if you're talking about speed without any direction, so you can actually paraphrase it, because again, for speed, that is without having any direction. So you can say that is the magnitude is 18, or the speed is 18 meters per second going to the left. You can just replace um, the speed as, I mean the velocity as, you have this going to the left, or your speed to be 18 meters per second. So that is your speed. So this is your velocity. Okay? So as expected, it should have a negative velocity because it should be going to the left. Okay? Thank you guys for listening. Um, for the next video. Thank you. Good morning.